full Python course, we'll be covering strings, or essentially how Python represents and works with text. By the end, you should be able to define what strings are, create strings using quotes, undertake basic escape characters, use keystring operations like concatenations, repetitions, indexing, and slicing. And we'll also be doing a few string methods just to get you started with those. That way you can be able to apply them later on in your code. So what is a string? String is a sequence of characters, right? Letters, digits, symbols, and spaces enclosed in quotes, right? And a few basic examples here would all essentially be looked at as strings in Python. So I'll just go ahead and copy and paste these ones here, right? So this one is a string hello. This is a string Python, string 123, string hello world. And we recognize them as strings because they are using quotes, right? So you can see a double quote here and you can see a single quote around here. So strings are how Python stores and manipulates text, right? Characters inside a string can be letters, they can be numbers, they can be punctuation, or even spaces. So anything that is inside um, the quotation marks, be it single or double, is going to be counted um, as a string. And for string literals, these are essentially strings written directly in code. They're usually surrounded by quotes as well, right? So we're going to do the same as we were essentially doing earlier with variables being assigned values, right? So here we are assigning this value of welcome to Python, which is a string literal to message, and we are assigning the string literal alias to the name, right? So if we go ahead and we print these two, we'll just go ahead and say print message. And for the second one, we'll go ahead and say print name. Now let's go ahead and run this here. Our console is going to take a minute. I can see our terminal running, right? So when we look at our console here, we do see that it's printing out the two. The first one is welcome to Python, Alice, right? So yeah, that's just a beginner use case for string literals and why they are important. So why the difference between the single quotes and the double quotes? One is mostly because if you're using strings, there's going to be occurrences where you would like to maybe use an so let's say you're saying I'm going to scissors, right? Or it's Tom's cut, for example, right? Notice that that already has a quotation mark. It would be confusing to Python if you use that in the middle, because it could terminate whatever string you're trying to write. So using both of these allows you to be able to, if you use a single quote one, you could use a double quote in the middle. And if you use a double quote, you could also use a single quote in the middle. And I'll show you how in a little bit. So let's first look at this example here. We'll just copy this into a file and run it as well. Right, so for this first one, we assigned the string literal of hello, and for text 2, we assigned the string literal of world. So this would essentially be printed just as it is, hello world, on two separate lines. All right, so we were talking earlier about when different quotes help. Let's run this example here, and you'll start noticing why. So when you look at this first line here of code, after the equal sign we have, it's a nice day. Notice that there is that one right there, right? You have a quote in itself right here, more like an apostrophe really. But if you don't have this, let us say we had this using a single one, for example, right? And we did use a single one at the end. Notice that the the string is already being underlined in red. And that is essentially saying, hey, that's going to throw an error. And we're going to try and run this, and surely enough, it's going to throw an error, and it's saying it's a syntax error, and unterminated string literal, right, detected at line 1. So this, by using this, the double, yes, by using the double quotes, we in that way make sure that this string does not terminate, and therefore is able to write the whole string literal as it is, even with that single quote in there for it's a nice day. Same for 2. We started and close it with the just a single quote, but instead we can have a double quote, right? So he said hello to everyone. So that comes in handy for that. We'll go ahead and print both of these since they're correct now. And we can see that on console it's being printed. For the first line of code, we have it's a nice day. And for the second line of code, we have he said hello to everyone. But both of them have quotes within the string literal itself. So that's one of the major perks for having both of them. So usually for starting and ending, it's better to just have a preference for the one that you prefer. It could be a single quote or double quote, but then it's important for you to remember that whenever you're writing the rest of the string literals, right? Because it becomes easier not to run into errors as we had seen previously. Okay, so this one we did see it break, right? So definitely whenever you write string literals, try not to use um, a single quote inside when you're using also a single quote on the outside. Okay. There is cases, however, that we could essentially avoid this, and this is when special characters come in handy to be used in strings. And a few common ones that are used in Python are this single quote here, right? So single quote inside a single quoted string, and this one for a double quote inside a double quoted string. This one for a backslash, this one here for a new line, and a backward slash t for tab. And we're going to look at a few examples of when we tend to use these ones, right? So let's copy this first code that we have here and go through it. Okay, and then all right, so let's look at this one here. We're saying in the first variable, we're saying a variable message equals it's a nice day, right? By using this backslash, right, notice that we're only using single quotes every single time, right? But previously we saw that when we tried to run this, it did break, right? But by introducing this backslash here, we're able to escape that single quote, and the line is not going to break, right? Let's go ahead and run it. We can see that it's printing here, right? So this did not break just because we're using this backslash here. So one handy use for it. And also we'd say it's the same for double quotes as well. We'd say it's best if you use double quotes to use single quotes inside. But if you find yourself in a situation where you want to use both as double quotes, right? So we see here double quotes closed here, but also inside we have double quotes. Then you could use this these backslashes here, right? And that will also you have to use 2 of them. That's why we say the double. This will also escape the double quotes, right? So we've already seen it run, and it printed as he said hello, right? So both of these lines do run correctly. All right. Another use case is, as we had said, the starting a new line, or essentially creating a tab within um, whenever you're printing your string letters to the console, right? So here we do have multi-line equals first line and then backslash n. So this backslash n is essentially telling Python to print a new line, and we'll see that once we run the code. And yeah, later on saying print multi-line here. Let's go ahead and do that. We can see that this here, which was essentially one string literal, is upon printing being printed on two lines, right? So backslash n is always essentially telling Python to print on a new line, whereas for tabbed, if you wanted something to be tabbed, then would use backslash t, right? So here we have item backslash t price. This means we want a tab to be created, or essentially place, uh, not place, sorry, space in between these two um, strings here. And after we'd printed, you did notice that there was a big gap right here in between the two strings being written. So they come in handy, so definitely do practice with this as we will in more examples. So just like we've already explained, backslash n moves to the next line, backslash t adds a horizontal tab space. All right, let's look at the triple quoted strings and why these are important in Python as well, especially when we're dealing with string literal. These come in handy when you essentially want to write multi-line text, or you want to add doc strings to your documents, right? And you can see here that we started here with text equals this, but we were able to write code or string literals that are covering this line, they're also covering this line, and we'll just close them from here, right? But all of this is essentially still part of this variable here that we've written, right? And when we say print text, we'd expect it to be able to print that. And we'll just demonstrate that here in a minute. All right, so it's running. This is line 1, this is line 2, this is line 3, right? So great and handy whenever you writing string literals within your code. Let's look at concatenations, right? So in a nutshell, concatenation is essentially addition of strings, right? Whenever you're reading a book, you read every word for word, right? So you read the cat is on the table. And essentially, when you're using strings in Python and you wanted to add multiple strings, even if they were in a table, you would need to use concatenation, right? If you're offered a first name and a second name in a table, and you wanted to instead print the person's full name, then you would use concatenation, right? So concatenation does the same as addition for numbers, only that you're just putting the strings or words next to each other. So let's look at a simple example here. First, we do have John, and we told that so for the first name variable, we assigned the string literal John, and the last name we assigned the string literal Doe, right? But we would like the full name, so we would say variable full name equals first equals variable first name, and then plus we add these two quotes with a space in between to add a space, right? So it's empty. It's going to be empty as well when we print it on the console, but the intent is to have a space in between the two, right? And then plus the last name variable, right? And remember, these variables are always going to print the values assigned to them. In this case, they're the string literals already assigned here. So when we go ahead and say print full name, Python is going to go ahead and concatenate those two string literals, and now we see on the console what is being printed um, is the full name, right? John Doe. All right. Another use case comes in handy is whenever you're printing things to the console and you want to use a string first to define whatever is being printed out, and then have the value also um, be displayed alongside that on the screen. And we're going to show that in a sec. So I'll just copy and paste this code here into a file, and then we'll run that. Okay, so here we've said age is 25, right? And we want to print age, right? So this statement here, because it's in the double quotes is going to be printed as a string, right, on our console. But notice here that the age is essentially, it's not a string, right? It's still a value, as in it's still an integer. So we would need to turn that into a string if we were going to concatenate it with this one here, right? We're going to run it first as it is, and because I need you to get used to seeing errors whenever you actually run code that doesn't make sense. So let us try to first run this one here. Notice that we're getting an error when we print. It's saying that this is a type error, can only concatenate string, not integer to string, right? So to correct this, we would need to specify that, okay, we want you to print and concatenate. So print on the console edge is going to be this one, plus let's convert this to a string first, right? I would have to close it again. Yep, let's do that. And when we run that, we do see that it's running edge being 25, right? So 25 as a string, right? It's a value, a number, 25. But this way, Python is recognizing it as a string to be able to concatenate it when displayed on the console. All right, let's look at repetition. Repetition uses the star sign, which we looked at as multiplication earlier when we were looking at the functions, the arithmetic functions, right? So what this does is for strings in Python, it essentially multiplies or replicates the string by the number of times that you're multiplying that string by, right? So here's a few strings to play around with, and just to explore a little bit more what it actually does, right? So here we defined a variable love, and we assigned it a string literal of ha. Now, what we want to do is we want to print the variable love and multiply that by 3 times, right? So we'd expect to get a response of ha ha ha, right? Because we're multiplying that string literal 3 times, right? When we print this, sure enough, what we get here is ha ha ha, right? So that string, whatever your string is really, if we multiply this by, let's say, 50, when we print, you see the ha repeating itself 50 times, right? And same here as well for, remember we said strings can pretty much be anything. It could be symbols, it could be letters, numbers, right? As long as it's in the in this quotes. So here we have this one, not in a line essentially, and we're saying we want to multiply that by 10. Actually, in this case, let's make it multiply it by 100, right? When we do that, notice that this line is being printed and repeating itself 100 times right here on the console, right? So that is it for the multiplication in strings. Now we're going to look at indexing, right? Indexing is really important because this has been used a lot in search, right? Whenever you're searching within strings, or yeah, whenever you're doing searches in strings, indexing is handy, and we're going to show you why, right? Indexing in strings typically starts from 0, which is the first character. That is the position that we assign it, right? So if a word is box, for example, B would be at value 0, or would be at value, no, B would be at position 0, or would be at position 1, and X would be at position 2, right? So always starts from 0. If you're trying to do the indexing, however, from the last figure, then you use a negative, and so it will be -2, -1, and actually more like, yeah, and then 0. Okay, so let us start with this example here. just to kind of make sense of what we've talked about. Right. So we have a text Python, right? And we're trying to essentially print. We're trying to print only the value that is at the location that we're mentioning for the string literal Python, right? If we want to print the P, right, we would have to print 0 or index location 0, right? Because that's where the P is located in the memory. If we wanted to print Y, we would have to print 1, index location 1 for Python. That's where the Y is stored. If we wanted to print T, it is at 2, right? Because it's the third one, but because for indexing we start at 0, then it becomes the second, essentially. And if we wanted to print N, as much as it's the 6th letter in the word Python, the index would be 5, because again we start at 0. So good rule of thumb is usually just subtracting 1 from whatever the number that you think it is. So if it is 6, just subtract 1 and it's going to be 5. That's your location index for the letter you're looking for. So let's go ahead and print this and see what they print for us on the console. We do see that we get a PYTN, which is exactly the letters that we're looking for when we did enter these indexes. All right, let's do another example just so you could get a better hang of this. Here they put a simple now for you. So zero-based indexing means the first character is at 0, the second is at 1, and so on, right? So positions are always going to be more like index 0, index 1, and 2, and so on, right? So box will be like that, as we talked about earlier. All right, I'll just go ahead and delete this since that's not what we're focusing on. Let's look at negative indexing, right? We say that negative indices count from the end, right? So -1 is the last character. Sorry, I flipped that around earlier. So -1 is the last character. -2 is the second to the last. This one is closest to natural counting, where you'd start from 1 and go to 2, 3, 4. Only that you're adding the negative since you're going backwards, right? Just to make sense of it, if we had, let's use box again as an example. In this case, since we're starting from x, I'll just go back up here. Since we're starting from x, this would be our -1 position, right? And this would be our -2 position. This would be our -3 position, right? So whenever we want to call any of these letters for the string, we would have to offer this position for that letter to be called. And we're going to show a quick example of that here, right? Here is our text, which is Python, and what we're trying to do is pull up these numbers using their location indexes. We have location index -1, which we can see here is the first one, so we'd expect to get n, and -2 is the second one, so we'd expect O. -6 is, okay, if we count -1, 2, 3, 4, 5, 6, we'd expect it to be P, right? And that's what we wrote here as well, right, as expected value. Let's go ahead and run this code and see the values that are going to be printed when Python computes these values, right? So we do get N or P being printed, meaning that this is these letters are stored at these positions within the memory, right? All right, that's enough for indexing. Let's look at slicing. Slicing comes in handy when you're trying to get a portion of a string, right? So maybe just from the start to the middle, or from the middle to the end, or from a certain value, index value, to another, right? We've already looked at indexing, so this should be just a continuation from that. So whenever you add the stat, okay, it's gonna be a little confusing here, so let's just take a minute to go through the explanation before we do the examples, just so you at per. Whenever you include start, it's going to start at the start, right? So if you have start to end, it's going to exclude the end, all right? If you leave out start, it's going to start at the beginning, right? And if you leave out the end, it's going to go until the end. So if you want to go until the end, leave out the end. If you want to go to the last value before the end, add the word, like add the last value or end value or end indexing, and vice versa for start. All right, let's look at the examples here. We're gonna do these ones real quick. Let's look at the first one here. So we have our text, which is Python still, and we're saying, okay, print this text here that are, yeah, print texts from the memory. Okay, let's say characters, since we already called a variable text, so it's not confusing. Print characters from text that are stored at these locations, right? So we have location 0 to 2, right? What we'd expect is we'll, because we don't print the last one, right? So we'd expect 0 and 1. That would be pi, right? For the next one, we have print the characters of the variable text that are stored at location 2 to 6, right? So we would start from 2, which is this one, because this is 0, 1. So we'll start from 2 and then go on to 3, 4, and 5, right? So we'd print all of this until n. We wouldn't print anything after that because we're not supposed to print 6, right? Let's go ahead and print this on the screen. We do see that this is, as expected, this is what is being printed on the console. The last one was a print text 1 to 4. We do see that our value here, y, is at location 1 because p is at 0. So we'd have printed y, and then t, which is essentially 2, and then h, which is 3, right? We would not have printed the value at location 4 because it's included in here. All right. So earlier on we explained why it's important to omit the start or the end. We do this whenever we want to include everything from the start or everything until the end, right? And this is what this slice here is doing. We'll just quickly put it out so it's easier to pay attention to it. So we have 2 lines of code here, and we're saying we're telling Python to essentially print, yes, requesting us to add this to it, but now we'll just run it as it is. Let's do that first. Okay, it's throwing some errors because we haven't specified text. Let's just go back here and clarify. So yeah, our text was Python. That's what we're using. All right. So I'll just write that first, so we don't have errors being thrown here. Okay. Yeah, it's saying that, but I'll just go ahead and skip it since we don't have to write that. Okay, so we say our text is Python, right? And we're saying, okay, so print all the characters from the start. By removing it, we're saying start from the wherever it starts from, that's where we want to start from. But we want our last value to be So I know we're putting the 3, and you may be tempted to essentially add the 3, but in using simple English, it will be every value until this value, but not including that value, would be a more precise way to explain it, right? So we're not going to include the plus 3, right? Or location 3. So we start from 0 to 1 to 2, right? and we're going to stop right there, right? So that's why we have P, Y, and T being printed on the console, but whatever is at 3 is not being printed, right? So it's up to that value, but not including that value. And same here now. When we say starting from 3 until the end, this is going to do everything um, carrying forward, right, from 3. So it's going to be including the edge or and end, right? So that's how to think of splits within strings in Python. All right, let's catch up with the rest. So let's look at changing strings or essentially creating new ones. But before we do that, the reason we do changes, okay, so if you have a text that you've already defined, for example, let's define, we've defined our variable here, text to be Python. We can't simply go on and be like, okay, you know what, go to this location, to location 0, and change that P to J, right? We can't do that. This is because Python and Python strings are immutable, right? So we can't make these changes. Otherwise, we'll get errors being thrown. And just to prove this one to you, we're just gonna copy this code here, and we will run it independently here. Just a second. There we go. Oh, we didn't print anything. So I'll just go ahead and say print. Actually, let me uncomment this one first. Right. Uh, Notice that when we run this, it says type error, string object does not support item assignment. So we cannot just assign an item to change it. Instead, what we would do is we would create a new string, essentially, and then we would um, then assign it a value and just add whatever was already in the previous text, right? So we have our text here. This is repeated. I'll just delete it. So we have our text as Python. We're going to create a new variable, give it a name new text. So variable new text equals, now assuming we want to change P for J, we would say new text equals J, and then plus um, characters from text starting from location 1, right? So location 1 would be Y without including P because P is at 0. So from location 1 until we left it empty, that means until the end, right? So when we print this new text, it's going to give us Jython essentially, right? Because we're combining, concatenating two strings, right? J plus the characters, other characters within a text. So that will be our new string. So this you can do in Python. You just can change within just the same variable. You just cannot change um, characters at particular locations. All right, let's look at length. Length is a function that's used to measure the length of characters in a string. We'll keep this one simple because it's simple counting, just as simple as adding every single character in there. So here we have a text, variable text, assigned a string literal of hello. When we say print length of text, it's going to go ahead and print everything apart from the quotation marks. So the double quotes won't be printed. So it will be counting HELLO. That is 5. So that's being printed to the screen when we run this. And then if we have it as just two double quotes which are empty, that would be 0 because no no character in there, right? The strings are empty, so it would just be 0. If we run this, we do see 5.0 being printed on the console, just to confirm that the code is running as we expected it to. All right, let's look at this one here. And this one does show an example where spaces or other characters are being counted as well, right? Because when we started earlier, we said string literals can be made up of letters, numbers, spaces, whatever is in the double quotes. So if there is a space, we must count it as well. So here we have a variable sentence is equal to hello world as the string literal. And then we're saying print the length of sentence, this string literal here that we have. When we run it, we're expecting a value of 13. I'll just run that to make sure the code is running right. And we see 13 being printed on the console. But we're just going to go back and count them individually. So you know how Python is computing this, right? We start with the edge. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So it's literally counting everything in here, spaces included. All right. Now let's dive into string methods, right? So string methods are functions that belong to string objects, and you call them with the dot syntax, just like we had looked at earlier in the previous episode when we were looking at math functions and calling them by importing math. We do the same here, right? By using the dot whenever we use the string methods. So the first ones we're going to look at are the dot lower and dot upper. These come in handy whenever you want to change your strings to either lowercase or uppercase. And we'll just run this example here just to show you how it works. So assuming we have a text which is Python, right? We have this under string literals, so that tells us it's a string. If we go on and then instruct Python to print this text here, so print variable text to lower, notice that we're writing text.lower, and then we close the we end it with the open and close brackets. This is part of the function, so we just keep it as it is. The value we assign it here at the start by just adding the variable, right? So we're saying print text dot lower, make it lowercase, or print text dot upper, make it uppercase. Let's run this. You do note that on the console we have both the lowercase and the uppercase for Python. All right, let's go to the next one. The next method is the dot strip. So dot strip is often used whenever you have white spaces and you want to remove them from your string literals. Just to show you how this works, we'll use this code here. So we have a variable row assigned this string literal. As you can see, the hello has lots of space at the start and lots of space at the end. Now we're going to create a new variable called clean, and we're saying clean equals row, right? So we're calling this variable here equals row dot strip. Then we add the method here, right, for strip. And then we're going to go ahead and print row and also print clean to show you the difference. So when we run this code, notice that on the console, we're having the first one is printed with the spaces because that is row. The second one is the clean one, and it's been stripped of the spaces. That's why you see there is no space at the start nor at the end, right? So that's the use case for the string method. The next one is replace. This one is often used whenever you want to change characters within string literals, or more like words within string literals. So we'll show you how this works here. We start off with the first variable being I like Python, right? So like any phrase in a book, it could be anything really, but you want to change that to maybe something new that you've been assigned. So we would go ahead and create a new text. And the way we call it, again, we start by calling the variable, so text dot replace, that is the function name. And then within the open and close brackets, we're putting the two values that we are replacing, right? So we're saying we are replacing Python with coding for that string literal, right? And then we're going to go ahead and print the new text. And we'd expect it to be a like coding by the time it prints. And when we look here in the at the console, that is what is being printed, right? So you can pretty much change it to anything that you want. I'll just add coding, and I also like, yeah, so I also like JavaScript, right? And that, if we run that, it goes on to change it to whatever you want. So great later on when it comes to data manipulation or essentially changing data that you've already been offered. So definitely a handy one to practice. We do have the .find substring, and this one is handy when you're doing search um, within you could be working with huge, like big documents, and you essentially want to find um, certain strings in them, um, and this is handy especially when you're dealing with like huge databases and you have data that may be identified by certain, maybe the names, or maybe just a mention of certain characters, or literally words that are within the text corpus, right, of pages that you don't have time to flip through every single one. It comes in handy when you can call it. And this is just going to be a simple use case. You, of course, would have to make it a bit more complicated to suit your use case later on, but this is just the start for how it works. So we have a variable here. We have assigned it hello world again as its string literal, and we're saying here print. We're instructing Python to print this variable. So text dot find. Dot find is our method here, and we're assigning the word that we want to find. Now, when it's looking for this word, it's going to go into the memory, check the memory locations, find the first instance where um, that word starts from, right? So it's not going to mention everything. It's just going to mention exactly where in the memory it is, so it can easily be searched. And would expect it to show 7. Let's go ahead and run this code. There it is. So it does show 7 when we write this code. We're doing the same here for the word Python, but notice that we don't have the word Python within this string literal. So what happens when we do run that? It gives us -1. -1 is a constant value that was assigned by the folks that wrote Python, and it essentially means that you can't find the value in wherever, like in the memory space that you're looking for, you're searching for it from, right? So whenever you see -1, just know that the word is not a part of the memory or whatever has been set there. All right. Next, let's look at string and number conversions. So earlier on, we looked in the last episodes, we did look at the use of string to convert numbers, not to convert strings and numbers. We use both the string one and we also use the integer one, right? So they're both interchangeable. You can use them to change each other back and forth. And as an example, we have this first one that we looked at earlier. So for age, we were assigned a value of 25. So if we wanted this as a string, we'll just have to add string here, and then it will be made a string. And the other way around, if we wanted it as an integer again, we'll just have to add integer here, and it will be turned into an integer. And just to give you an example of how this works, we'll just use these 6 lines of code. So for the first one, we have a variable num string with 42 assigned to it, but notice that 42 is a string, it's not a number. Well, more like it's a number, but it's not an integer, since it's identified by Python as a string. So for us to make it an integer, we would essentially create a new variable that we're calling num equals int, and then inside there we would add this variable here that we want to convert to a string, to an integer, right? So we're saying int num string, and then we would go ahead and print this new variable here, and then add one to make whatever calculation we wanted to make, right? So for this one, we just wanted to add one, and that would expect to give us a value of 43, right? So here we get 43. What would happen if we did not convert it to an integer first, right? Let's go ahead and I'll just comment this one out, so Python is not going to read it. Now I'm going to use num string, right, to call this one here since it was already assigned. And I'm saying +1. So notice here that instead of actually doing the math of 43 plus, okay, so here it's throwing the type error and saying can only concatenate strings, not integers, right? What if we made this a string as it's saying, right? Because it's saying we cannot concatenate different, like we can now concatenate a string and an integer. So we've just made both of them strings. When we run this, notice that it's actually writing 421. So instead of adding the numbers and making them 43, because there was strings, it just got the 42 and concatenated the one as a string to the end. So it became 421, not 43, right? So very important for you to pay attention to such details, especially as the code base gets larger and larger. That'll be the same case here, right? We have a pi string as 3.14, right? So if we want to make it a float, we just have to say pi, make a new variable pi val, and say equals a float, right? And then enter this same variable here, right? So we're saying make this variable a float, and then we go ahead and print that value and do whatever other calculations we wanted to do. And surely we did get 3.15 for this one, right? Because we had already assigned it as a float, or changed it from a string format to a float format. All right, let's go back here. So that is most of it. The practices are really stuff that we'd already covered. We'll just go through them quickly. You can always pause this later if you want to practice. Just don't want to make this this episode longer, so we can carry on to the next one. But for this one, we have a text, assigned programming. So if we're going to the memory locations, to look in these memory locations, questions generally, this often comes on interviews, or just to kind of check your knowledge on memory locations using strings. So if we're to run this, we'd actually have to print all of this. So just go ahead and say print A and print B, print C, right? You can go ahead and print all of them. I'll just print those for now. And when we print this, notice that it does print the letters of the string that are at those locations that we had already assigned, right? So go ahead and print all of them, look at the values, and try to figure out why those values are being called as per the explanations we got through earlier, right? So here are the answers that I'd expect you to get if you run that. So just try to make sure that you get the same answers as well. And probably the last example using strip, that would be a good one to use as well, is this one here, right? So you're starting with a text, which is a Python, and then you're creating a new variable, right? So new text equals text at 0 dot upper. So make the first one, make the first letter uppercase, right? So that's what text location 0 dot upper means. And then plus text 1 to the end is saying concatenate the rest of the text from position 1 to the end, right? So this makes it uppercase. And then the other code is essentially saying clean equals s dot strip. So remove the spaces from this one here in s. This is another practice example. So remember we said strip removes the empty spaces. This is essentially what it's doing here. Length after clean is calculating the length after removing the spaces, whereas if you just calculated length of S, you would essentially be calculating the length with the spaces included, right? Upper clean equals clean.upper. This one essentially makes the whole of this one uppercase, right? We'll just run this one so you can see how it works, or the results that are going to be printed onto the console. So, oh yeah, I didn't emphasize the printing. So let's go ahead and say print. Yeah. So print length before. All right. Then we'll go ahead and print length after. Okay, we'd also go ahead and print upper clean, and also would print clean, right? Since these are the variables we did calculate. So when we run that, we do get, yeah, 20 and 14 for the length for before and after. And then there's ones essentially with the use of the upper method, making it uppercase or lowercase, right? So play around with this, and I'll see you in the next videos. If you have any questions, just feel free to share them in the comments, and absolutely be sure to check out the next episodes or topics in the Python Full Course playlist to advance your Python skills. All right, see you in the next one.